Good morning students. Today we are going to discuss few numerical from the chapter 2 units and measurement. Now the related formula which we are going to use here already we have defined in our previous class. Now let me discuss this numerical. The moon is observed from two diametrically opposite points A and B on earth. The angle theta subtended at the moon by the two directions of observation is 1 degree 54 minute. Given the diameter of earth is about 1.276 into 10 to the power 7 meter. Calculate the distance of moon from earth. So these are the values provided in the numericals, and what we have to find, the distance. So please go through this. To solve this one, you have to go through the topic which we discussed in our last class, that is your parallax method. Now the 2 point of observation is your A and B, and A and B is at the point at the extreme ends of the diameter, and the diameter of the earth is given 1.276 into 10 to the power 7 meter. So B is your 1.276 into 10 to the power 7 meter, and theta, that is parallactic angle, is given 1 degree 54 minute. So if you have to convert degree into minute, what you have to do, you have to multiply by 60. So 1 degree is there, so 1 into 60 gives you 60 minute. So with 60 minute we have to add 54 minutes, so ultimately we will get 114 minute. Now from 114 minute you have to convert it into second, that is you have to multiply with 60. So 114 into 60 gives you theta in terms of second. Now please check out this conversion. 1 second is nothing but is your 4.85 into 10 to the power minus 6 radian. This is already defined. Now we have to convert the second in terms of radian for angle theta. So theta is your 114 into 60 second. So 114 into 60 into 4.85 into 10 to the power minus 6 radian. So theta you have converted in terms of radian. Now this is your known formula, B equal to S theta. B is your base, basis basically, not base, basis. It is nothing but the distance between 2 points of observation, and S is your distance from the object to the point of observation, and theta is the parallactic angle. Theta is the angle made by the two sides of observation with respect to the basis. So S is equal to B by theta. So S is your distance. What we have to find, calculate the distance of moon from earth. Here the object is the moon. So the value of B is your 1.276 into 10 to the power 7, and theta is your 114 into 60 into 4.85 into 10 to the power minus 6. So please go through this simplification part. I have written directly. It's your 3.84 into 10 to the power 8 meter. So check the calculation. It's a very simple calculation. So S is nothing but is your 3.84 into 10 to the power 8 meter. So that is nothing but the distance of moon from earth with this given data. I think you have understood. Only you have to know the conversion, second to radian. So second to radian you check out. You will get this thing in any standard book, standard reference book, this conversion part. Now next one, a radar signal is beamed towards a planet and its echo is received 7 minutes later. Okay, so to and fro motion takes the time 7 minutes. If the distance between the planet and the earth is 6.3 into 10 to the power 10 meter, calculate the speed of signal. So this topic also we have defined, that is your reflection method or echo method. So the formula which we are going to use here, D equal to Vt by 2. Now V is your 2D by T. So D is given, D is your what? That is nothing but the distance between planet and earth. Okay, distance between planet and earth is your 6.3 into 10 to the power 10 meter. 6.3 into 10 to the power 10 divided by that is your time. Time is your given here 7 minutes. So second, 7 into 60. So if you simplify, you will get 3 into 10 to the power 8. It should be meter per second, not the second itself. It should be meter per second because V is in your speed, no? So be careful about the unit. So it should be your 3 into 10 to the power 8 meter per second. I think you have understood this calculation part with the given values. The time is 7 minutes. You have to convert it in second, and the distance between the planet and Earth, that is d, that is nothing but is your 6.3 into 10 to the power 10 meter. Now the next sum which we are going to discuss, the parallax of a heavenly body measured from 2 points diametrically opposites on equator of Earth is 1 minute. If the radius of Earth is 6400 km, find the distance of heavenly body from center of Earth in astronomical unit. So what are the values given? 2 points, observation is from diametrically opposite points, and the angle is your, this is parallactic angle is your 1 minute. So theta equal to 1 minute. Single dash is your minute, so you have to convert it into degree. So 1 by 60. So again you have to convert into radian, that is your pi by 180. So theta is in terms of radian. So in all the numericals you have to convert theta in terms of radian. Now next is your the formula B equal to S theta. B is the basis, S is the distance, and theta is the parallactic angle. So you have to calculate distance here as per the requirement. If the radius of this, find the distance of heavenly body from the center of Earth. Radius of the Earth is given 6400 km. Now opposite points of the means here the parallax of a heavenly body measured from two opposite points of diametrically, 2 points of diametrically opposites, that is radius is given. So B is your distance between 2 points of observation, and it is diametrically opposite, and the radius is your 6400. So it should be 2 into 6400. It's in kilometer, so you have to convert it into meter, that is multiply with 1000, and theta is your 1 by 60 pi by 180. 2 into 6400 into 1000, 60 into 180, that is pi is your 3.14. So go for the simplification part, that cancellation and multiplication part. So here the value coming out is your 4.4 into 10 to the power 10 meter. But in the question it says that express this one in terms of astronomical unit. So and one astronomical is given 1.5 into 10 to the power 11 meter. So you have to convert this one in terms of astronomical unit. So 4.4 into 10 to the power 10 divided by 1.5 into 10 to the power 11. It is in terms of astronomical units, and the value coming out is your 0.293 astronomical unit. So this type of numerical you will get in your exam. So please check out the numericals, and the formula is very simple. Only the conversion part, minute to degree, second to minute, or minute to second, or minute to radian. This conversion you must have to know, and simple formula, that is your arc equal to angle into radius. This type of formula you have to use. Already you know this formula, so you are using that one directly. And for reflection you have to use, that is your 2d equal to vt. So because it covers twice, no, and the time is your t, so that's why 2d equal to vt. So you please go through similar numericals, because in exam you will get this kind of numerical. And if you have any query, please put that query. And one thing I want to keep it in your mind, that please download the videos at the very moment of the class, because due to technical issue these videos may get deleted. So be careful. So whenever there is a class, don't let these things afterwards. Thank you.